Welcome, Algebra 2. This is section 2-4, more linear equations. The essential question is, what does the point-slope form tell you that the slope-intercept form does not? Let's begin. So we got two new forms of a linear equation today. We did slope-intercept form last section. So the first one's point-slope form, and here's the point-slope form. Y minus y1 equals m times the quantity x minus x1. Well, y and x are just the x and y coordinate of a line. Your y sub 1 is going to be y coordinate of a point. So the y coordinate of a point. You have to pick some point. And your x sub 1 is actually just that x coordinate of a point. So you have to pick some point on that line, and it's going to be some point x1, y1. You just, one point in that line, you need that for the point slope form. Your m is still going to be your slope, just like in slope intercept form. So the difference here is we need some point on that line. Doesn't matter which point that is, just some point. So you can use any point in that line to write point slope form. So I'll use this first one. We'll call that point A. So if I use that point A, and what's the slope of this line? Well, you can kind of tell that the slope is going to be the change of y over the change of x. So one way to look at it with that graph is if I'm going from this point right here, A, to let's say go down to this point here, B, well, how much am I going down? I'm going down, this is at 5. I'm going down 1, 2, 3, 4, 5, 6. I'm going down 6 to get on the level of B, and I'm going across 1, 2, 3, 4. 4. So the slope m of this line is going to be negative 6 over 4, the change of y, which was negative 6, and over the change of x, which is 4, which reduces to negative 3/2. So that's my slope. So let's plug in a point. Now the coordinates for A are going to be at 5, oops, I'm wrong with that. It's the x values first, so it's negative 2, 5. So the points of A, so I can write the equation as y minus y1, which will be 5, equals the slope, negative 3/2, times the quantity x minus negative 2, so I can just say plus 2. And that's one way to write this equation. Another way to write this equation, let's use this point, C, way down here. Coordinates of C look like they're at 6, negative 7. So let's plug in 6, negative 7. So this will be y minus y1, which is 7. So it'll be plus 7 equals negative 3/4 times x minus 6. So that's another way. These are the same equation right here. They're just two different ways to write it. It's an equation for the same line. Another way to write a linear equation is called standard form. A times x plus b times y equals c, where a, b, and c are just some real numbers, any real number. X, and one way to note when we're doing standard form, x and the y's are both on the left side. So before it was the y was by itself on the left and the x was on the right. So now we're just shoving them both to one side, and we're putting the constant term, just constant numbers, on the right. So to convert from a standard form, I need to get the x's and y to the left and leave the constant on the right. So if I want to convert this equation right here, this x has to go to the left side. So to remove that x, and it's a positive 3/4 x, I subtract 3/4 x to both sides. And then that happens. These will cancel out. And what I'm left with is negative 3/4 x plus a y equals the constant term negative 5. So this is my same equation in standard form. Okay, when do we actually use these three forms of the equation? Well, slope, intercept, point slope, and standard form. We use slope intercept when we know the slope m and we know the y-intercept. So whenever you have that y-intercept, it's good to do slope intercept form. Point slope form is when I know that slope m, but I don't know the y-intercept, but I know some point. Just some point. It doesn't matter which point. If I know some point that's not the y-intercept, I can, let's erase that. If I know some point that is not the y-intercept, I should just use point slope form. All right? Or when I know 2 points, because if I know 2 points, I can come up with the slope. Standard form, I don't think you really use this much. You'll see it written that way sometimes, but the focus really is on slope intercept and point slope form. All right? So let's look at another few things, and you learned this last year too. Parallel lines. These are when slopes are equal to each other. So you got two lines in parallel right here. They'll never cross. They just sit there in parallel a certain distance from each other as far as you go out to infinity in both directions. they'll still be parallel and they'll never cross. So your slopes are the same. So here's the equations of these two lines. Notice the slope in both of these. The first one's m equals 2, and the second one's m equals 2. They're the same slope. They have different y-intercepts, 5 and -3. This one's at 5, this one's at -3. And that's good, but we have the same slopes. Key is the slopes. So perpendicular lines, slopes are opposite reciprocals. What's an opposite reciprocal? Well, when I say opposite, that means you flip the sign. So opposite means to flip the sign. So you go from positive to negative, or you go from negative to positive. Reciprocal is when you flip the fraction. Flip the fraction or flip the ratio. So you go to a ratio like 3/2, and it flips, so it flips to 2/3. So you just flip in the place up and down. So if we combine this opposite reciprocal, we have to flip the sign and flip the fraction. So let's look at the case of these two lines. The slope for the first one is m equals 4. The slope for the second one is m equals -1/4. Well, to find the reciprocal, we flipped the sign and flipped the fraction. So I took this 4, which is 4/1, and I flipped the sign. So I converted this into -4/1, and then flip the fraction means you flip it upside down, so it'd be -1/4. So this is why the slope for the second line is -1/4. It is the opposite reciprocal. Try this example. Pause the video. Alright, what is the equation of each line in slope-intercept form? So a line that is parallel to y equals 6x minus 2 and goes through point 1, -3. So equation of each line in slope-intercept form. Okay, so it's got to be in slope-intercept form. So y equals mx plus b. And it has to be parallel to this. Well, the first thing it says a line parallel. Well, if once we have a line that's parallel, that means the slope has to be the same. So I know my m has got to be 6. So I've got to find my y-intercept b. And then I can create this equation in slope-intercept form. I know it passes through the point 1, -3. So I don't know the y-intercept, but I know some point, so I can use the point-slope form. Y minus y1 equals m times x minus x1. So I'm going to plug in what I know into slope-intercept form first. So it's going to be y, and I'll call this x1 and y1. So y minus -3, so +3, equals m, which is 6, times x minus 1. So this is point-slope form. But I can convert this to slope-intercept form by just distributing and doing a little bit of math. Because the goal with slope-intercept form is to isolate the y. Get that forever alone. So I'm going to distribute the 6 to both terms. So I get 6x minus 6 equals y plus 3. And now to isolate the y, I got to get rid of this plus 3, so I subtract 3 on both sides. So now I have y equals 6x minus 9. And this is my slope-intercept form answer. So we had to first find the point-slope form to get the slope-intercept form. Alright, pause the video. Alright, what are the intercepts? So when I talk intercepts, that's x-intercept and y-intercept. These are where the line will cross the x and y axis. So the neat thing about intercepts, let's talk about x-intercept first. Whenever you do x-intercepts, your x-coordinate is going to equal some number. We'll just call this x sub 1. And your y-coordinate, because it's crossing the x-axis, it's always going to be 0. So we know our y value is going to be 0. We just got to figure out what x is. So we can just plug that in. So we get 3 times x plus 5 times 0, because we know y has to be 0, equals 15. So these 5 times 0 cancels out. I'm left with 3x equals 15. And I can divide by 3 on both sides. So my x is going to equal 5. So my x-intercept happens when x equals 5. So I look at my graph, I'm going to draw a dot right here. And I'm going to label this point. It's going to be at 5, 0, because that's my x-intercept. Now let's do another point. Let's do the y-intercept. So y-intercept happens when you have a 0, because it's the y-axis right here, up and down. X is going to be 0, and y is just going to be some number. We got to figure out that number, so we plug this in. So plug in a 0 for x into the original equation. Get 3 times 0 plus 5y equals 15. 3 times 0 goes away, so I get 5y equals 15. Divide by 5, and you're going to get y equals 3. So that happens at y equals 3. I'm going to go up to 3 and put a dot right there, and I'm going to label that point 0, 3. So those are my 2 points. And when I've graphed 2 points of a line, or plotted 2 points of a line, I can graph a perfectly straight line between those. So I'm going to use my skills of this, and hopefully I can draw a perfectly straight line that goes through both points. And it should look something like that. Make sure you do little arrowheads. And that's a pretty good line. So all we had to do was graph it, found 2 points, which were the intercepts, and graphed it. That's it.